Today, we're diving into the story of a hidden vulnerability that brought some of the world's fastest blockchains to their knees, and, more importantly, the ingenious system that was built to stop it. This is the story of Beluga. All right, let's jump right in. What you're looking at here is a high-performance blockchain in big trouble. See, normally its latency, its processing time is measured in milliseconds. But under attack, look at that. It's spiking to over 4.5 seconds. In the world of high-speed networks, that's an absolute eternity. It means the entire system is grinding to a halt.
So, that's the big question, right? How does this even happen? What kind of attack can cause such a catastrophic failure in a system that's literally designed for speed and resilience? Well, that's the mystery we're about to solve.
It turns out the answer is kind of ironic. The vulnerability lies in the very thing that makes these blockchains so fast. In the race for performance, they took a shortcut, and that shortcut left a hidden door wide open. Okay, so to get this, we need to talk about something called block synchronization. It sounds complex, but the idea is simple. For a blockchain to work, every computer in the network, they're called validators, has to have the exact same information. They all need to be on the same page, literally, at all times.
Now, to get that blazing speed, many of these systems use a two-phase shortcut. First, there's the optimistic push. A validator just blasts out new data and kind of hopes everyone gets it. Then, if someone misses that broadcast, they have to go into phase 2, the reactive pull, where they basically have to ask around, hey, did anyone get that block I'm missing? And this is where it gets really interesting. The researchers who found this vulnerability had a great name for it. They called this whole mechanism unstructured glue code. Think about that. It wasn't a carefully designed system. It was more like a quick fix, a band-aid, that worked well enough most of the time, so it just stuck around. A temporary solution that became a permanent, hidden risk. And there it is. That's the key to the whole thing. This informal, good enough process. That's the hidden vulnerability. It's the crack in the foundation just waiting for someone to come along and exploit it. So with a weak point like that just sitting there, you know someone's going to find a way to take advantage of it. And that brings us to the attack itself. This wasn't some brute force assault. It was an elegant, almost perfect exploitation of that very weakness. They called it the pull induction attack. And get this, the whole thing kicks off with just one bad actor. A single malicious validator in a whole network of dozens of honest ones. So here's how it's supposed to work. A new block gets broadcast to everyone. Simple. But the attacker, they do something very sneaky. They send their new block to just one other validator. And boom, that's the trigger. All the other validators, they see references to this block they never received. So what do? They all trigger that pull mechanism at the exact same time. It creates a total network storm, a chaotic mess of redundant requests with everyone screaming, hey, does anyone have this block? The impact is immediate and massive. The time it takes to complete a single round on the network instantly triples, and that's the bare minimum. The entire process just grinds to a crawl. And that's how you do it. A network storm, triggered by a single malicious node, causes the entire system to stall out. That's what creates that crazy latency spike we saw right at the start of all this. Mystery solved. Okay, so the problem's been found, the crime's been solved. Now we need a hero. And that's where a much smarter system comes in, one designed to stop this exact kind of attack. It's called Beluga. So what exactly is Beluga? Well, think of it as a complete, structured replacement for that vulnerable glue code we talked about. It's not a patch, it's a properly engineered system designed to do the job right. Beluga is smart, and it has a couple of superpowers. First up, a reputation system. Validators basically keep score on each other's behavior. So if an attacker consistently forces everyone else to go fetch its blocks, its reputation just plummets. Then, the honest validators learn to prioritize information from more reliable, high-reputation peers. Superpower number 2 is what's called a hybrid pull strategy. This is really clever. Beluga doesn't treat all missing blocks the same. It categorizes them. Live blocks are the time-sensitive ones you need right now, while bulk blocks are less urgent and can be picked up later. And this makes the whole system so much more efficient. For those critical live blocks, Beluga pulls from all validators at once to get it as fast as possible. But for the less urgent bulk stuff, it just pulls from one validator to keep the network traffic low. It's the perfect balance between speed and efficiency.
All right, that all sounds great on paper, but you know what really matters? Does it actually work in the real world? Let's take a look at the impact.
Wow, I mean, just look at this. This slide says everything you need to know. On the left, you see the system collapsing under attack. On the right, with Beluga running, the latency barely even moves. The attack is completely, totally neutralized.
And let's put some hard numbers on that. The results are just wild. With Beluga, the system under the exact same attack has 3 times higher throughput and an incredible 25 times lower latency. I mean, that's a total game changer for network resilience. And you know, this isn't some theoretical thing cooked up in a lab. Beluga is out there, in the wild, right now. It's fully integrated and live on the Sui blockchain. So why does all this matter? Well, we're not talking about small potatoes here. Beluga is now helping to secure over $10 billion in assets on that network. It went from a research paper to protecting immense real-world value. And that really brings us to a bigger idea, doesn't it? The story of Beluga is all about replacing that unstructured glue code with a well-designed, principled system. It really makes you wonder, what other shortcuts in the complex systems we rely on every day are just waiting for a smarter solution to make them stronger, faster, and more secure?